So plyometrics, I always think of his examples of like doing this or the jumping jacks. So plyometrics is the eccentrics followed by concentrics. So in this example, it's whenever the same muscle is going through eccentrics and then overcoming the force to go concentric. So you're concentrically doing your horizontal ad, and then eccentrically to slow down, you have to do eccentrics of AB. So you're eccentrically contracting and then concentrically contracting. So it's that portion where it's like eccentric, concentric. That is the plyometrics part. Another easy way to remember is I think of like bicep curls. It's like the hardest part of the movement. So whenever you're doing like a preacher curl or something, you're going down, and the hardest part is when you have to overcome like your momentum going down. So you're eccentrically contracting followed by concentric. So it's that concentric part at the very end. So, or like, I know he did a hammer one for us where it's like you're swinging it and your elbow flexors are concentrically contracting, then your triceps are eccentrically contracting to slow it down because that's the only way you can slow movement down is eccentrics. And then your triceps are still firing eccentrically and then concentrically they speed up. So that little eccentrics to concentrics part is the plyometrics. So it's mainly that it's like a small section of the whole movement. But if you like, he also stated how like first he introduced it as if you slam your hands together or if you like slam the hammer down, that part of it is there's no plyometrics because you don't have to start letting up. Like you don't have to do the eccentrics because your force is being stopped by like a wall or your hand. So like this, there is no plyometric because my own hands canceled out the force here. I didn't. You'd have to overcome it and go back the other way. That's how he introduced it in the beginning. I think I like wrote that down. Yeah, he'll either do like I know the examples we did in class were like jumping jacks, the one with it's like adduction, abduction, and then hammer. It's a functional movement where you're trying to speed. Like today, he talked about like sprinting. Like that's one too, where you're trying to move fast. And then also kind of gets into when you're going with gravity. So when you're going with gravity, you follow the same formula that you do for each other type of practice problem, where you look at the agonist, you look at the force, except the force this time would be so if you're let me think if you're trying to swat a fly, the force would be trying to extend your elbow and you're trying to move fast. He'll say something like moving as fast as possible, so you'll know agonist should be going with gravity. You're trying to move as fast. You wouldn't do the opposite of gravity because then if you wanted to swat something fast, you'd slowly. If you just went like eccentrics, you'd slowly go down. But you're trying to move as fast as possible, so you're going to concentrically contract, and you're going to go with gravity. So that's the only different part from all our other ones. It's going the agonist is the same direction as what the force is. So then you would once you have those two, you can just solve for the next two because then the motion would be elbow flex or elbow extension. So it'd be like force, elbow extension, agonist, elbow extenders, motion, elbow extension. So it's like the same the whole time. And then this is a small Kahoot because it's just I've already given a lot of practice problems, so there's probably like there's not that many more practice problems I can give. Like I'll have more after this, but Kahoot is just trickier to do because I have to keep redoing it each time. So what is the agonist at the trunk? Let me turn up the volume. I wonder why the Kahoot doesn't have volume. Okay. All right, so let's see. The agonist at the trunk, so when I first look at this, every single time I do that formula, I think, what is gravity trying to do? If she just stopped where she was, she'd have right lateral bending. So then you know she's going to use her left lateral benders. And then that's all this question was asking for, the agonist. So you really just had to do the first two steps. Yeah, see, you just have to, for this one, imagine her just relaxing, and what would happen to her body? She would fall to the ground, like her hips would go to the ground, and then this would be bent. So this one just kind of, you have to envision it, and then really, if you're committed during the test, you can get up and do it and see what gravity's trying to make you do. You would right laterally bend, so then you know you're going to be using your left lateral benders. You'd feel a burn on this side of your body. I don't know why there's no audio. Oh, there we go. So you can do the same steps I just said. Perfect. Yeah, it's, he likes to do questions like that where it's, because this one it's kind of tricky. If you think, oh, we used the left lateral benders last time, it's got to be left lateral bending. The neck is different because if you just work through the problem, if she dropped her head, she'd fall to her left side, so then she's gonna need her right lateral benders. So it's kind of the opposite. This side would be burning, and then this side would be burning. If you feel a burn, then I don't really know if you would. So this is a stretch question. So for stretch questions, it's always just the opposite. That's how I remember it. Yeah. So, and there's like a cheat sheet. You can use it on your body during the exam. If you want to stretch your right lateral benders on your neck, you'd have to bend to your left. So it's just the opposite. If you want to stretch your biceps, you would. If you want to stretch your elbow flexors, you would do elbow extension. Like, it's kind of, once you get that, it's kind of, you can apply it to every single joint motion, and then you'll forever see it. You just have to do the opposite each time. So agonist and contraction. So for this one, at least, you know, if you picked green, you know that it was isometric, because showing one image, you can't assume motion, so you immediately should know isometric. So what is the agonist? You follow, what's gravity trying to do? It's trying to bring his feet to his right side, so that means his sternum would be more lined up with his left hip. So that means he's having more left transverse rotation. So gravity's trying to left transversely rotate him, so you're going to need your right transverse rotators, and then you know the contraction's isometric because there's no motion.
Okay, if his legs were more to the other side.
So in that case, force would be trying to or right transversely rotate him. Yeah, so then he'd need his left transverse rotators. So if you just follow the same formula every single time, so if you mean like his feet are on the other side, or like he's going upwards towards the middle?
Like, I'm thinking like the whole gravity thing,
Mhm.
like what's if gravity's pulling you towards one way?
Yeah, so I just imagine if you relax the muscles, his feet would fall this way, his sternum would be more, basically, he would be doing like, it kind of doesn't make sense, but he'd be doing this because his feet are falling more this way, so his sternum is lining more with his left hip. So he's starting more like already turned, but then if his gravity wanted to do what it would do, it would go like that. So then you're more left transversely rotated, so you'd be needing your right transverse rotator, so his feet wouldn't fall. It's like a whole puzzle, but once you use the formula over and over, and then if his feet were going the other way, it's the same thing. Gravity's trying to right transversely rotate him. So you wouldn't want to turn on your right transverse rotators, or you would yank yourself to the ground. You would need your left transverse rotators to prevent that. And yeah, this is another type of question he can ask where it would be isometric, but he's giving you a motion, so it's not isometric. So if you did the formula, you would fill in motion with, you fill the M part in with whatever he gives. So in this one, pronation. All right, so for this one, at least, supinators is the correct answer. But, so, let me do it in front of the camera. So the weight is trying to pronate you. So gravity and the weight are going to do the same thing. So pronation is going to be occurring. So you're going to need your supinators, and you observe pronation. So supinators do pronation through eccentrics. Concentrically would be supinators supinating. But in the description, I said you observe pronation. So only way that supinators allow pronation is through eccentrics. And that's the end of the Kahoot, but we have a bunch more questions. I just didn't do a big Kahoot because it's easier to do practice ones. Like this is if you guys wanted to go over this, we can, but this one is a bunch of new questions. But like even some of these are repeats because there's only so many questions you can kind of come up with before it starts getting repetitive. So we can do some of these and then we can get into like, if you guys want more stretching questions, more plyometric questions, or like when you're going with gravity. So, oops, I'm gonna show it. So this is from left to right.
Wait, do we have that doc?
Is that one the more?
Oh no, wait.
It's like a PDF.
No, I sent a lot of PDFs. I think I did. I'll send this PDF after class, or I can do it right now. Let's see. How would I do that? If I go on group. Let's see. Let me go to GroupMe and send it.
Okay.
But y'all can start working on it. Let's see. it's gonna have the answers on it. So if you guys like on your thing, if you can block it out or just zoom in to where you don't see the answers or work through it, you can do it like that. But this is just, I'm just gonna put it in the GroupMe document used during review. Okay. All right, from left to right. So if I were to solve this first, I'm looking at what the force is trying to do. The force is trying to evert the foot, subtalar joint. So remember, it can only evert or invert. So I know I'm gonna need my inverters, and from left to right, I observe inversion. Inverters doing inversion concentrically. Yep. And then from right to left, so always remember, if it's the same force, you're gonna use the same agonist, and the motion is going to be the only thing that's different. So then if the motion's different, you know the contraction is going to be different. So y'all can solve from left to, or now y'all can solve from right to left. I mean, this is just a bunch of examples kind of that we've, similar to the ones I've already gone over or sent out. So it's kind of repetitive. So if you guys would rather have specific questions or like would rather see specific ones, I could just Google something and we could go over that. Like Google an image. So from right to left, it would be same force, same agonist, except this time it's going to be eccentrics. And then from left to right on this one, this is all subtalar. Well, for these problems are subtalar. So in this one, force would be trying to invert you because of the band. So you're going to need your everters, and your everters are, you see eversion happening, so it's concentric. At this point, these should kind of be easy. We've done these all the time. And then from right to left, you know, same force. You're gonna need the same muscles. Only thing that's different is the motion. So now instead of eversion, you see inversion. So only way that your inverters allow eversion is through eccentrics. Yep. And then this is ankle. This one is a still picture, by the way. Not ignore the arrow going up. So in this one, you can do it yourself. Gravity is trying to cause dorsiflexion, so you're going to need your plantar flexors. The motion, there is no motion, so it's isolated. Yep. Are you guys confident in like the other type of questions, like stretching? Because I feel like these are just, we've done these over and over and over. So do y'all want any like stretching plyometrics or like with, like when you're trying to be as fast as possible?
Wait, I have a question.
Okay.
Okay, for joint motion,
Mm-hmm.
why would it be like plantar flexion?
So through the little formula. So when you're doing it, gravity is trying to bring your ankles down. So that's dorsiflexion. So when your toes are planted, that's why I think plantar flexion. So gravity's trying to bring you down. That would be less plantar flexion. So that's dorsiflexion. So gravity's trying to dorsiflex you. So you need the opposite. You need plantar flexors. And then there's no motion. So it's isometric. So I'm trying to think of another way to explain it. Like, if you do the motion yourself, you're fully plantar flexed. But if you just let gravity win, you would be less plantar flexed. Therefore, dorsiflexion is occurring.
So in any like isometric picture,
You would
it would
still
always
do.
be no motion.
Yeah, no motion
Okay.
at all. If he just gives a still picture, it's no motion unless he says you observe this from this picture. But if it's just like this and there's no, you can't assume, that's the whole thing where he's like, you can't assume this or that. You can't assume that they're going up or down. So you have to just take the picture as is. I think there's another example. There's a lot of, isometrics are the easier ones because as soon as you see a still picture and he doesn't say like you observe this motion from this, you know immediately what the contraction is. But he most likely will ask what's the agonist as well, because it'd be pretty easy to do the contraction if it's isometric and he doesn't ask for agonist. So he normally asks for both. So like this is another example.
Would you want to do like some examples on plyometrics?
Yeah,
Like
we
how
can.
they-
You can do a plyometric with this one. If you imagine her doing a full range of motion, what would the plyometric part of the movement be? So you can do that as well after. I'll ask it again after we go through what this is.
Is that how you would ask it on the exams? Like
Yeah.
what are the plyometric-
He would like what, or he would say like what is the section of the movement? So it would be like this eccentrically followed by concentric. So it would be like I'm gonna ask it how he would on this question right here with this picture.
So like with a plyo question, would he give us a start and finish, or would he could just give us a still photo?
He could do either or. He most likely would give like a motion picture, and most likely like one of the examples we've done in class, because we didn't do that many plyometric examples in class this semester. I remember when I took it, we had like a few classes just for plyometrics.
Can you do like the formula thing for plyometrics as well?
I don't. I just imagine it and just know I'm looking for the eccentrics and concentric part of the movement, and I know eccentrics is the only way it can slow down. So I don't really follow a formula for that one. So for in this one, the machine is trying to cause knee. If she just let go, let her muscles relax, this is the force in this equation, her knees would extend. So she's going to need her knee flexors, that's the agonist, and then no motion, so isometric. Knee flexors, isometric. And then you guys can work through the plyometric sequence of this one if she was doing a full range of motion. So to solve for the plyometrics in this one, you're looking for the eccentrics first. So if she was going down with her knees, so her knees are extending, she's eccentrically going down, and then the plyometric sequence would start right whenever she starts starts going down, and she slows it down, and then the same muscles are firing the whole time, but then she's concentrically contracting to bring it back. So the same muscles eccentrically letting it go down, and it's overcoming the weight again to concentrically come up. So it's the same muscle each time, like during the whole movement, except eccentrically is slowing it down and then concentrically to bring it back up fast. And then another example it's frozen. Oops. Another example would be like a jumping jack question. So you can try to solve this one. I just wanted a picture of a jumping jack, but you can kind of just imagine it in your head. But his hands don't touch. We kind of did this one in class a while ago. So at the top, mainly just focus on his arms. I would just do shoulders. So at the top, but your hands don't slap together. So they do that, and then they come back down, and then that, and they come back down. All right, to solve for this plyometric problem, so you're abducting concentrically because you're abducting, your arms are going up, and then to slow down, you're going fast. So during plyometric problems, you kind of assume they're going fast. They go fast, and then to slow down, you need to eccentrically activate your adductors, because that's the only way to slow down is eccentrics. So you go up, your adductors turn on, but you're still going through abduction. That's why it's eccentrics. And then at some point, it switches from eccentrics to concentric to adduction. So that point is a plyometric sequence. When it's going concentric, eccentrics, then concentrics. And then literally another plyometric sequence would be at the bottom. It's whenever it just switches back and forth. So this would be a plyometric sequence. This would be a plyometric sequence. This would be a plyometric. That would be a plyometric. Like every time you switch from the eccentric portion to the concentrics. It's like whenever the hardest part of the movement where your muscles have to overcome all the force, you're going this way, then go back down the other way, and then overcome all the force you did that way to go back the other way. So it's like the most damaging part of the movement, I guess you could say, for the muscle. Do you want another plyometric, or like you think you got it? Okay, yeah.
Wait, real quick.
Mhm.
Sorry. Okay, so we're abducting concentrically, and that's picture 1 and 2.
Yeah, I just wanted a picture to show you.
Yeah, that's
So
fine.
you're going up, and then his hands don't touch, because then if your hands touched, then there
Then
would be
it stops, but then
yeah.
just doing this.
So yeah,
And then
you go like this, and then you're.
abducting
to s-
eccentrically, but then adducting concentrically.
It's hard because it's like ab and ad. So you're abducting, and then to slow down, like you start slowing down probably here when you're doing a jumping jack. So to slow down, you eccentrically are firing adductors, but your arm is still going up because of the momentum. So you're eccentrically doing it to slow it down, and then once you start going this way, that's concentric adduction.
Okay.
Yeah.
So like on the exam, we would have to switch between abduction and adduction.
Yes, it would be for machines. It's a little bit simpler because like this picture where the knees are extending, it's eccentrics, then concentrics, but it's the same muscle.
Yeah.
But whenever it's not machines, you're going through abduction, then adduction, then abduction, then like so it switches between two muscles, but the plyometrics part is when it's the same muscle going from eccentrics to concentrics.
So I have two agonists here, basically.
Yeah, but I don't even use the formula for that. I just have to
Okay,
kind of
okay,
go
okay.
through that process in my head. Like I'm looking for eccentrics and concentrics, and then you can like work it out through your joint motions where it's like, okay, I see abduction here, and I know that's concentric because I'm speeding up, and then to slow down, like I can't just keep going. I have to start slowing down. So eccentrics, and I know it's the only way to slow down is fire the opposite. So abduction and then adduction is going to be what's slowing it down, but it's eccentrics because it's not like if I did adduction immediately concentric, it would just go straight down. But you have to slow down a little bit if you're going fast. So then you're eccentrically slowing it down because it's pulling. That's what he says. Like muscles pull the same way no matter what. So it's constantly pulling. Like once I start firing my adductors, it's pulling, but it's considered eccentrics because I'm still abducting while my adductors are firing. But then once my adductors start going in the adduction direction, then it's concentrics. It's like a
Which would be a different sequence, or like still the same.
The plyometric sequence is the I don't really know.
Like going up,
Mm-hmm.
concentric, but
And-
you have to stop yourself once you get here. So like
Ye-
that's one full sequence.
So it's concentric,
Right.
and then at some point your
Right.
adductors start firing to slow
Right.
you down eccentrically because
Right.
you're still doing abduction.
And that ends one phase or one sequence.
I don't really.
No.
I don't
That's
think
not
that's not really the part. Really, just the plyometric part where it's the eccentrics, your muscles firing, and it switches from eccentrics to concentrics. And like you could do the same thing at the bottom of the movement because you're adducting concentrically, and you need to slow down. So your abductors are going to eccentrically fire, then concentrically fire. So like there's a plyometric sequence here and down here. As long as they don't smash together, because then
Right.
that's what stops you, but not your muscle stopping it. But we didn't focus that much on plyometrics. We focused mainly on questions like this. So he even said today, like, we spent like 80% of class doing questions like this. So you can expect a good chunk of your exam to be questions where it's like force, agonist, motion, contraction. And he'll ask like agonist, contraction, things like that, kind of like what the Kahoot was. There'll be some stretch. There'll probably not be as many isometrics because those are the simple ones and they're pretty simple. So he wouldn't ask a bunch of isometrics. He would probably do a little bit of isometrics, a little bit of concentric, a little bit of eccentric, and then like a few stretch questions, a few plyometrics, and then maybe like maybe one or two where your agonist is firing in the same direction as gravity. That's like whenever he says moving as fast as possible. So if there's a roach on the ground, you're not going to eccentrically go down. You're going to activate your muscles that stomp. So you'd activate your hip extenders, even though gravity is trying to extend your hip. So like this normal, let's see if there's an example. I don't doubt there is, but basically the formula where it's like, oh, gravity's doing this, so I need the opposite. In those examples, that's not, whenever it says as fast as possible, it's like, okay, gravity's doing this, I'm going with gravity, so I don't want to slow down because, so in this example where there's a roach on the ground, gravity is trying to extend my hip, so I wouldn't fire the opposite muscles to stomp. I would fire the same muscles to go as fast as possible. So your force and your agonist would be the same. And then the motion would also be the same. And then so the motion and the contraction are the same, it would be concentric. Yeah. And it's like, you can also say the hammer, would the hammer one be one? I don't know. But yeah, it's the questions where you're doing a functional movement as fast as possible. So he'll state that. Because all of these questions are like slow and controlled. Like you're not trying to go as fast as possible, faster than gravity. But in questions where you're trying to go faster than gravity, that's when you're going. Yeah, the hammer would be one because you're not trying to slam the hammer softly, eccentrically. You'd be activating your muscles that are pulling with gravity. I guess we can do a stretch question because those are. Let's see. You can just look at one of these and just do it. Okay, for this one, what is she stretching? If she's has her from her left hip, like what is being stretched here? And like stretch questions are pretty simple. You see there's left adduction occurring, so you know she's stretching her abductors. And that's the one where you have like the answers are like your joint motions themselves. You want to stretch your elbow flexors, extend your elbows. If you want to stretch your right side of your neck, you're going to bend your neck the opposite way. But he could ask questions like, how would you stretch your blank? And then you should be able to answer it from there. Like, it doesn't have to be a picture. Any other do y'all want to do like the windshield wiper questions, like, or like this one basically? Are you guys, I mean, we've done these a lot, but yeah, we can try it. So in this one, if she just relaxed and her legs kind of fell, she'd let gravity win. Her sternum would be lined up with her right hip more, so she'd be more right transversely rotated. So we wouldn't need right transverse rotators to twist her trunk. We'd need left transverse rotators. And isometric, so no motion, isometric. We can do like a pull-up question. Let's see, pull up with the scapula. Here's the one that we can use. Okay. What? Oh, there we go. Okay. From left to right, what's happening at the scapula? So if you guys remember, we have protraction, retraction, elevation, depression, and upward rotation and downward rotation. Remember, in the pull-up questions, if your arms are above your head, you're actually upwardly rotated. So it's like a little hint. Your scapula right now is upwardly rotated, and as he starts going higher and higher, his scapula starts downwardly rotating. Because his humerus, that's how I focus on the humerus. It's all the way almost vertical above his head, and then it starts and this is like 90 degrees, and then now it's almost to the side of his body. So if you imagine the scapula, it's like, if I could draw it, I would, but it's right here, and it's almost like a U shaped, and then here it's like a C shaped, or it's facing to the left. So in this one, gravity, if he was just hanging here, gravity is trying to keep him upwardly rotated, so you're going to need your downward rotators. The motion from left to right is downward rotation, so downward rotators doing downward rotation concentrically. And then if I said right from left, you could do it that way. You should be able to simply follow the same steps, and you know gravity doesn't magically change. Your agonists aren't going to change either, so that's another important thing. To realize that if the force stays the same, that means you're using the same muscles no matter what, like if you go left from right or right to left, you're using the same agonists. The only thing that's changing is the motion. So now instead of concentric, it would be eccentric. Let's see. Either of these are okay. All right. All right, and this one, the force is trying to protract you, so you know you're going to need your retractors. And then from left to right, you see the scapula retracting. So retractors retracting concentrically. And like all these can be found, I'm pretty sure, in one of the documents I've sent. I know I went over it in one of the review days, so it had to be in one of the documents. Let's do one from here. Let's do this. I haven't done much wrist. So from top to bottom. All right, from top to bottom. So if she just relaxed her wrist, she would have ulnar deviation. So you're going to need radial deviators. And then from top to bottom, you can see that ulnar deviation is happening. So radial deviators allowing ulnar deviation eccentrically. Isometric, yeah. I mean, that's really it. If you guys have any specific problems y'all want to go over, we can do another one where it's like the guy on his side, but if not, if you guys are confident with the stretch, so it's stretching, concentric and eccentric, like the ones we've been doing in isometric, plyometrics, and then going with gravity. Those are the main ones, and there might be like a general knowledge one. He kind of said it today in class, I think, where it was eccentrics are the most damaging part of the movement. So like kind of not basic knowledge, but general knowledge questions. But mainly it's going to be what we've gone over today, mainly focusing on like the formula that we've used. But if you guys don't have any other questions, then y'all are good to go. I'm going to stop the recording.